Namaste students, I JVWU Indu, Assistant Professor, Department of Science and Technology, Faculty of Education and Mathology, JVWU Women's University. Today I will discuss 8085 basics. So let's start. We will start from address bus. We know that bus is the set of lines and it is used to carry information, or you can say that it is used to transfer information. Address bus is used to carry address and it will select the location in the memory. 8085 has 16-bit address bus. It means it can access 2 to the power 16 memory locations. Now, we will find the size of the memory for 8085. 2 to the power 16 means 2 to the power 6 into 2 to the power 10. So it will be 2 to the power 6 means 64. 2 to the power 10 means 1 kilo. Byte. It means the size of the memory for 8085 will be 64 kilobyte. We represent with the capital B the byte. We represent the byte by the capital B. So the size of the 8085 memory is 64 kilobyte. The size of the memory depends on the size of the address bus. In the 8085 microprocessor, address bus is 16-bit. Therefore, it can access total 2 to the power 16 memory locations. Therefore, the size of the memory of 8085 will be 64 kilobyte. The address range for the memory will start from 0000H and it will end at F F F F H. Suppose this is the memory. In the memory, different locations are available. These are the locations. The address of the first memory location is 0, 0, 0, 0, H. Here we will write address and this is for the data. So the first location of the memory has the address 0000H and the address of the last location of the memory will be F, 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 H. Address will be in the hexadecimal. This is the first location. And this is the last location. Each memory location can store 1 byte of data. In the 808 microprocessor, each memory location can store 1 byte of data. Suppose at the 0000H memory location, the data is 32. (32H) is a hexadecimal number and it is of 8 bits. The binary of the 3 is 0, 0, 1, 1 and the binary equivalent of the 2 will be 0, 0, 1, 0. It means 32H is a 16. 32H is a 8-bit number. 8 bits equals to 1 byte. Suppose we want to store 16-bit data. So we will store the 16-bit data at 2 consecutive locations. Suppose we want to store 3121. It is a 16-bit data. So to store the 16-bit data, we will follow the little endian rule. We will follow little endian rule. According to this rule, we can store the lower byte of data at the lower address range and the higher byte of data at the higher address range. Suppose the next memory location is 0, 0, 0, 1H. And next will be 0, 0, 0, 2H. So 31 is the higher byte of data and 21 is the lower byte of data. 0001H is the lower address range and 0002H is the higher address range. So lower byte, according to the little endian rule, 21H will store 80001H memory location. And 31H will store 80002H memory location. Now we will discuss about data bus. Eight zero eight five microprocessor has 8-bit data bus. This means that 8085 can transfer 8 bits in one cycle. Next is ALU. Eight zero eight five has 8-bit ALU. This means in one cycle, 8085 can operate on 8 bits of data. Therefore, the 8085 microprocessor is also known as 8-bit microprocessor. Next is control bus. Control bus releases the control signals. These control signals will decide which operation must be performed. The main control signals are IO, M bar, read bar, write bar. IO is 1 for IO operations and 0 for memory operations. IO so IO M bar, it is a control signal when the value of the IO M bar is 1. So IO M bar is 1 for input output operations. IO M bar is 0 for memory operations. Read bar will be 0 for read operations. And write bar will be 0 for write operations. So today I will discuss about basics of 8085. I hope you are satisfied with my today's digital session. If you have any query, please mention in the comment section. Thank you.